So, everyone ready? Should we start? Well, what better JavaScript modules? What's a better topic to start a, the kick off the day with something that can start a flame war within the event? For that, I would like to welcome Nicolo. Fun fact about him: if he asks you to go on a train ride with him, run away as fast as you can. It's a trap. And yeah, what else can I say? Let's applaud Nicolo and let's start the presentation.
Hey. So before starting, I'll blame all my train problems on him. OK, so JavaScript models past, present, future. I've been working on models in TC39 for a while. I am working at Igalia, and we've been doing this together with Bloomberg. And well, working in TC39 means like designing the future of JavaScript. But let's take a very big step back. And welcome to your history class. So models in JavaScript have not always been like this. They are a pretty new thing. Like many years ago, we used to do this. Just stick a script tag in our code that loads some code and that attaches some new variables in the global scope. And we didn't really need modules. Like we didn't have many files. JavaScript applications were small. It was like just a little bit of interactivity. And like this was perfectly fine. And until when it was not fine anymore. And specifically for server-side JavaScript, applications started to become more and more complex. And in 2009, like a group of people decided to work on what is now known as CommonJS. And fun fact, it was originally called Server.js because this problem was only on the server and not on the client. There was a need for a standard way to load other files, to load other code, namespacing them without just sticking everything in global scope to avoid like conflicts. And for those who don't know how CommonJS looks like, we have this require function which like loads a file and returns some object. And to export values from our modules, we have this exports object to which we just assign variables. And when we will import this object, this module, the require function will return the exports object of this other module. And that doesn't just work as is, because require and exports are not really like something defined in the browser or in a JavaScript standard. So there is a wrapper function that provides us with this require exports and like modules and other CommonJS specific utilities. And we all now know CommonJS for modules, mostly for Node.js modules. But CommonJS was not that. It was an effort to like create some set of built-ins shared by all the server-side environments that you could reliably use. It's similar to what is now WinterCG. Like I've seen there is a breakout session on this day about that. So that's like I was not there in CommonJS Day, but it feels something very similar to what other people are doing now. And what we now refer to CommonJS was actually called CommonJS Modules 1.1. Well, there was 1.0, and then 1.1 is what we have now. It only defined the interface, so that there is this require and this exports object, not how modules are loaded. And this has been implemented by many server-side environments, such as Node.js. And CommonJS was great, and many people have been using it for many years. But it has a problem. It's that require is a synchronous function, and so it doesn't really work in browsers, because you don't want the main thread to synchronously wait while your file is being loaded from the network. So people working in this CommonJS group came up with something which was called CommonJS modules/asynchronous definition, which was a way to pre-declare all the dependencies that we needed to run our code, so that they could be first loaded asynchronously, and then once everything is ready, we could execute our main code. And this is better known as AMD, which came just 1 year after CommonJS. And well, it has this define function where we can list all the imports and utilities you want, such as require and exports, if you want to use a CommonJS-like interface. And beta is an example of an external module that will be loaded somehow and will be like available when we later synchronously execute our code. And like you can see, this is very similar to CommonJS. It's mostly a wrapper or there are other ways to use this that are like less similar to CommonJS. And it had some other differences from CommonJS, such as an asynchronous require function, because it's not always possible to statically declare everything that we will need. So this require function allowed to load things from the network later. And AMD supported plugins. And these allow creating custom models type, customizing how models are resolved, and it uses that like plugin name, exclamation mark syntax that maybe other people know for Webpack. I think Webpack inherited the syntax from AMD. And CommonJS AMD, and after 5 years since AMD was released, we finally had a standard way of defining modules that was supposed to work the same across all the environments. So on the server or on the browsers and everywhere else we can run JavaScript. It has this syntax that, well, like many of us work on JavaScript, so I'm sure many of us already saw these export and import statements. And it has some advantages that share with AMD and some with CommonJS. It is statically analyzable, so exactly as in AMD, the runtime can preload all the dependencies it will need, and then later, once everything has been asynchronously loaded, it can start synchronously executing the code. However, it has a minimal syntactic overhead. We don't have to define this wrapper function and list in this somewhere at the top of the file all of our dependencies. We can just use import statements that are very conceptually similar to the required functions that we have in CommonJS. And ESM supported both named and default exports without reusing the same object, either a default export or as a namespace, which is what both AMD and CommonJS did. And it took very long time to define how CommonsScript models should work. And by very long time, I mean that in 1999, people already started to think how, TC39 was already starting to think, how could we standardize models in JavaScript? How would they look like? And there's been different iterations, some more similar to CommonJS, others more different. At some point, they started as syntaxis sugar on top of what was CommonJS. And there have been ideas for modules for updating scopes. Import statements were at some point proposed to be very different from what we have now. This looks more like Python than what we have in JavaScript. And there were discussions about how to customize loading modules, what are the different stages for loading modules, and so on. And 4 years later, CommonJS, ESM gained a feature that both CommonJS and AMD already provided since the beginning, which is how can we load a module that we cannot statically declare? And dynamic imports were introduced. They're very similar to the asynchronous require function that AMD had. We load something, and then when it's ready, this API was promise-based, not callback-based, it's conceptually the same. And a couple of years later, ECMAScript modules also got top-level await, so that we don't have, we can, for example, use this dynamic import syntax at the top level of a module without worrying about callbacks. And that's what we have now. That's how we arrived to what we have now. But what's the situation for models today? Well, modules are being used in productions and as a distribution format. CommonJS and AMD is still very popular, like NPM, JavaScript. Most of JavaScript modules in NPM are still written or are still published in CommonJS. Most people write ESM in their editor, but then they compile it to CommonJS or to something else, because CommonJS still works better with the node ecosystem in most cases. And there is not clear migration path for libraries written with one module system with an older module system to ECMAScript models, because yes, you can just rewrite your code, but then not all the functionality is there. It might be harder for your consumer to import your libraries, and there are different problems. An example of something that's missing from ES modules and that CommonJS provides is a way to synchronously import dependencies not at the beginning. Maybe you have some file that is very heavy to import, it does some heavy computation, or we just want to defer doing unnecessary work unless it's really necessary. With CommonJS, we can just use this require function wherever we want, such as inside another function. And this heavy computation pie will only be loaded if we actually call the circ function. ECMAScript modules don't let us do anything like this. Another example is that AMD supported writing multiple modules in a file. Bundling AMD modules was very easy. It was mostly just concatenating all of the individual modules, and then the runtime, the AMD loader would like link them together. And with ESM, we cannot really concatenate all the modules in a single file because we have to be careful about scope, about how top-level await interacts with other modules, about how do we verify the module namespace objects if you use the like import star syntax. So it's not as easy as it was before. And also, I showed before that AMD supported a way to customize module loading, to define your own module types, and ESM doesn't really have something like that. And also, the integration story for the languages in ESM is still not as good as it could be. And so ESM is great, people are using it, but there are still problems. And within TC39, there is this effort that we call modules harmony. Harmony is like an overloaded word in TC39. It was already used for like what is then called ES6. It's nice. It means that everything will at some point play well together. And okay, these slides were actually not for today. Like, I assume most of you have already heard of TC39, but like it's the JavaScript committee that defined how JavaScript should work. And we've been talking, we have these recurring meetings every 2 months, and we've been talking about modules harmony like at every single meeting for the past year at least. Like you can see March, July, September, and then also like in all the subsequent meetings, there were always modules topic. Like the people working modules were pushing this, and like everyone was always forced to focus on modules at every single meeting. It is actually nice. And we've been discussing about how the different proposals related to modules can work together, how can we be like harmonious together, how can we create a coherent story on them, and how can we decide what to ship, what to not ship, like in which order the different like features, the different missing functionality should be added, and so on. So we have this, like we've been talking about this, but like what is this in practice? There are, well, maybe, because they're still old proposals. So things might change, things might get standardized, we might decide that something is a very bad idea and end up not doing it. So we have been talking about 6 main proposals. The division in proposals is not always clear in this module space because there are like, the space is so big that we often find ways to refine the proposals division. Some proposals maybe get closer, or some proposals get split in different functionalities. Like this is a good way to think about what we're doing now. You don't need to read all of them now because we're going through all the proposals one by one. Okay, so the first one I want to highlight is import attributes. It's a stage 3 with an asterisk, but we can say it's stage 3. Import attributes gives us a way to pass some parameter to the underlying module loader. So when a JavaScript developer writes this import statement, importing like the math.js module, the JavaScript engine asks to the runtime to load this module. What does this JavaScript engine ask to someone else mean? So by the JavaScript engine, I mean things like SpiderMonkey or V8. They only implement the like main ECMAScript standard. They don't have I/O capabilities, and they rely on some other wrapper to communicate with the outside world. And this other wrapper is usually a browser. It can be something like Node.js or Dino, or like all the different JavaScript runtimes that you might have heard about. And like I'm keeping this division between the two because like the JavaScript engine is what works the same across like all the places you can run JavaScript, while the wrapper capabilities can change. So when the JavaScript engine asks to the wrapper runtime to load something, the wrapper runtime will, for example, do a fetch request to a server or load a file from the network after resolving the import specifier to a URL or to a file path. Then the server will reply with some code, like it's basically a string, and the runtime knows that it's a JavaScript string, so it gives to the JavaScript engine the instructions how to execute that file. So it says there are these exports. You can execute it using this function. That this function will then just be the JavaScript engine evaluation function. And so what if we want to integrate integrate our module system with something else? The JavaScript engine is not about JavaScript, but we might want to load, for example, CSS modules. And we cannot really define what CSS is within the JavaScript specification. So import attributes are a way for the developer to just tell to the JavaScript engine to forward some information, such as type CSS. The browser will see that it has to load this module with this type CSS attribute. So the browser knows what type CSS means. So it can load a style sheet. Right now, all modules are loaded the same way. But we've designed now things so that the browser can tell to the server, hey, I want a style sheet module. Hey, I want a JavaScript module. And the server will then reply with some code. It has, at least on the web, the JavaScript, the wrapper runtime will check that the MIME type of the requested module matches what the user wanted. So type CSS is correct. So the import process proceeds. And the runtime wrapper then gives the JavaScript engine some response, abstracting away the fact that this is a module. So exactly the same as it did for JavaScript modules, it just defines the interface and how to evaluate this module. And so this allows all wrapper runtimes to integrate whatever language you want in an opaque way that the JavaScript engine doesn't need to know about. And there is a big warning regarding this proposal, which is you've likely already heard about something called import assertions, which was a previous version of the proposal that allowed just verifying that the loading module had some properties, and it used the assert keyword because it was just failing the process if the module didn't have some properties defined somewhere else. While integrating this with HTML, it came up that those was not the expected semantics. And so the proposal has been updated to be something more generic, like import attributes that are not just assertions, can actually affect how a module is loaded and what a module is. Second proposal, I think this is stage 3 now. Okay, still stage 2, source phase imports. Stage 2 means that we are still refining how the proposal should be done, and it's not implementation ready yet. So things may change. Before looking at what the proposal is exactly, let's take a look at how modules are loaded. So we have our module who's let's assume we're on the web, so modules have an URL. We have this x.com/main.js module, and this module has a global object, has its own URL, and it imports a dependency, such as this ./mod.js. So how does this import work? First, the module that we want to load has to be resolved. So we have to compute the full URL of the modules we're loading. Once it's resolved, we can, the wrapper runtime can fetch or fetch and compile the module. Then we attach some context to this module, such as the global environment in which it must be executed, its URL, so that when it can use this new URL to load its recursive dependencies. And then we link all the modules with all their dependencies together. And this is a recursive process because we have to walk the whole module graph, making sure that everything is loaded, everything has its own execution context, everything has its own URL where we can load transitive dependencies from. And after everything's linked, so our modules graph is ready, we can finally evaluate all the modules in the correct order, depending on how different dependencies between all the modules are defined. And what this proposal does is to basically expose the module at an early phase. So the important module would not go through this whole pipeline to these 5 steps. It would just stop earlier. Specifically, it would stop after fetching and compiling the module. And the syntax look at this. So we say we only want to import the source of mode and not to do the full process using the source keyword. And we get back an object representing this source. And why are we working this proposal? The main motivation is to improve the WebAssembly integration in JavaScript. Right now, when you want to execute some JavaScript code, you have to first manually get the URL of the module you want to, of the WebAssembly module you want to use. You have to manually fetch the module using, for example, the fetch API. Then you have to manually compile the module to get something which is called a WebAssembly module. And then you can later instantiate it, linking it with all the dependencies, and evaluate it. This proposal allows skipping the first steps. So instead of having to manually load a module, you can statically declare that you want some WebAssembly module to be loaded, and then you still have to manually link it. So you get the source of the module, basically the bytes wrapped in a WebAssembly.module object. And this is a great improvement compared to what we have today, because first of all, it has bundlers a lot, and like all JavaScript tools, because they can statically see which dependency you're using. And also, it allows much better integration with the content security policies that we have on the web, because it's not just a random fetch and then evaluated some code that we loaded from somewhere else. You can actually go through the existing security pipeline for JavaScript modules. And there are other ways in which we could integrate WebAssembly modules with JavaScript modules, such as a full integration where we just import values from WebAssembly modules as if they were JavaScript modules. There is also there was work ongoing in this direction, but both have their advantages, like the manual linking that the source phase imports proposals provide is more flexible, and so it works with any type of WebAssembly module, even if they don't know about how dependencies are loaded on the web. Because if you would want to use the fully abstract way, WebAssembly modules would have to know about URLs, would have to know about how to specify the dependencies that work in browsers, and they would have to specifically target the web when being compiled. And okay, so third proposal we are exploring. This is still stage 1, which means it's actually just in the exploration stage. We are still we know what we're trying to solve. We might not have we have some ideas of what a solution might look like, but these ideas are still very up in the air. Which is the third import evaluation proposal. We saw many slides before that CommonJS allows lazily requiring some modules. We just have this synchronous require function. We can use it wherever we want. And it's not really possible to do the same with JavaScript modules. Yes, we have dynamic key import to dynamically import dependencies, but we cannot just rewrite this code from CommonJS to SM like this, replacing require with import, because the import is asynchronous, so we have to await its result. Our circ function becomes asynchronous, and this is annoying, because once we have an async function, all the callers need to be updated to be asynchronous, and async await basically spread across our whole code base when we just modify a single small function that is used by everything else. So can we somehow solve this by keeping this deferral process synchronous? If we look back at the phases we saw before, we see that there are some asynchronous parts, specifically fetching a module from the web. But what if we first do the synchronous parts and then only defer the last steps? We only defer what we can actually do synchronously later. So this proposal exposes a module at a different stage in this pipeline, specifically after linking and loading all the dependencies. So it has a similar syntax based on this keyword after the import keyword. This proposal uses defer. When the JavaScript engine sees this import defer statement, it will load the computed.py module. It will fetch all the dependencies. So this might be asynchronous. This happens before starting to execute the code. But it doesn't evaluate it. It skips the last step. So that then when we later actually use this function, when we access the export of our module, so doing mod.py and then in space, it will trigger the evaluation and complete the evaluation process. So this is not as on the web, we cannot defer as much as we can defer with CommonJS, because the web is asynchronous. But we can still save some significant amount of computation until when it's actually necessary. And going deeper in proposals that are like at the base level of how modules work, we have custom module loading, which is again stage one proposal. We have an idea of what we want to solve. We don't know how the solution will look like yet. So we have, we saw a couple of slides before this like back and forth between JavaScript engine, some wrapper runtime in the middle that talks with a server, with a file system, and we saw this pipeline. And I didn't mark it before, but like some parts of this pipeline are defined, are like implemented in the wrapper, specifically the parts that rely on I/O. And then we have some phases implemented in JavaScript engine because they work the same across everything. They're fundamental to how JavaScript works. What if we allowed hooking into what the wrapper runtime does? So that we could, for example, have our own module resolution or simulate how modules work in Node.js by doing it on the web or vice versa. Can we provide ways to customize these, like these first steps? Right now, this is already possible at some extent. In browsers, we can use service workers to intercept module loading. So when the browser asks to load a script, instead of talking directly with the server, there can be this service person in the middle that intercepts the HTTP requests. It can like reply with something or load something that's from the server. Then, like in this example, it just loads the same file from the server, but then the server replies with a TypeScript file. And well, web browsers don't support TypeScript, but our service worker could like intercept this response, compile it on the fly to JavaScript, and give it back to the browser as JavaScript, pretending that like this TypeScript thing didn't happen at all. And so we can have different module types on the web somehow. And this is basically replacing the fetch and compile phase because the browser pre-resolves the URL and then expects us to give back a fetched source. Node.js is something similar. There is a flag called -- experimental loader that sits between the Node.js modules loading process and the file system. So when Node.js wants to load a file, instead of going directly to the file system, it can go through this loader, and it allows hooking into resolution and into loading. So, yeah. So the resolve and fetch and compile phase. What the proposal does is to provide a way to completely abstract away that part using the same API across all the different runtimes, so that we have a single way to do so that works the same everywhere. The JavaScript implementation, the JavaScript engine would not talk with the wrapper runtime anymore. Instead, would refer to this import hook function that JavaScript developers can define that take the specifier of the module we're importing and has to resolve the module, to fetch the module, and then to return a module together with its context. So this is replacing all the phases that are defined by the wrapper runtime. And yeah, and most notably, this proposal would introduce the concept of a module. You can see this new module constructor that defines a module with some custom import behavior. And this is something that's existed in JavaScript. Like we have first-class functions, unlike other languages, but modules are still something that sits below the language and that JavaScript code cannot really interact with. So this proposal would verify modules as first-class values in the language. And from that, we can move to module expressions, which is stage 2. So it's a little bit ahead of this custom module loading proposal. And like, what are module expressions? So we have, like as I mentioned, functions that are first-class values, and we will have modules that are first-class values. And we can create functions using the function constructor. I hope no one does this. And similarly, we can create modules using this module constructor. Or for functions, we can also use a static syntax to more easily declare functions line. So module expressions give us something equivalent for modules, which is much better than just creating code from strings, because like it has, we are not evaluating strings of code that might come from somewhere else. So with potential security issues, we get all like better integration with all the tools like linters and editors, because it's just JavaScript code and not a string that could contain anything. And similarly to like functions can be called, the module expressions can be imported because they're modules. The motivation for module expressions is not actually just like this proposal. This other proposal introduces a module, so we need an expression form of that. I have a missing slide somewhere, but module expressions allow defining multiple modules in the same file. Right now, there was a like one file, one module pairing in JavaScript, and with module expressions, we have a module that contains an inline module, and this module could then be passed around. You could pass the module to another file, to another function. You could even pass the module to some other context. Like you might want to serialize the module and pass it to a worker, or like to anywhere else. So this proposal would allow collocating code that is logically related, regardless of where this code is actually executed. So it would like lower the barrier for creating code that can be like executed. Like the main reason is for workers. Because right now creating work is difficult. You need a separate file. You need to resolve this file around time. If you are providing some library, your library doesn't have a single entry point anymore. It has 2 entry points, and so you need to make sure to properly resolve that entry point. And module expressions solve this by allowing to actually collocate code and like providing a single file. And okay, then we saw that functions have the expression form and module expressions have the expressions for modules, but functions also have a declaration form. And do modules have something similar? There is a different proposal, which we decided to keep separate because it solves different problems and it has different challenges that we need to solve, called module declarations, that basically gives us the declaration form for modules. And I mentioned many slides ago that when migrating to these old module systems based on like wrapper functions to ESM, we don't really have an easy way to bundle anymore. Bundlers are very complex tools, and because it's very difficult to bundle JavaScript modules. So once we have module declarations, bundlers could just like start concatenating again files in the same module. They would just need to make sure to rewrite the import specifier to refer to like the internal modules instead of external modules. But this very much simplifies how it's done, because like tools wouldn't have to re-implement all the JavaScript module semantics. They could just declare those modules, and they will be executed by the browser used by the JavaScript engine using the existing like module semantics that are implemented for single file modules. And this is all. Yes, this is all. So we've gone through these 6 proposals. There are like some other discussions going on that don't really fit in our proposals, but these are like I think a good overview of the general space. And like when are all of these proposals coming? Are all of these proposals coming? Like I mentioned that they are different stages. Some are already stage 3, so they're approaching definite shape. But like for many proposals, we're still in the exploration phase. So feedback is welcome, and like feedback might be, oh, I would really use this proposal, but it needs some tweaks. Or like this design is perfect as this. Feedback might also be like, this is a very bad idea. You shouldn't do this at all. So, yeah. Well, hopefully we will solve some of those problems that old systems already solved, and even solve problems that were never solved before yet in JavaScript. And fingers crossed, and let's see where we go. Okay, this was the last slide. Thank you.
Thank you, Nicolo. I had a question for you, if you don't mind.
Yeah.
One thing you mentioned that was really interesting was the whole life cycle of import attributes and how they've gone through the different cycles. Are there any lessons for web standards authors that you want to share?
Yeah, so what happened with the proposal is that it was designed as attributes as import assertions to respect some existing guarantees that JavaScript modules have. Right now, you import a module and you're guaranteed to always get the same module if it's like if in the same file you import the same module twice, like with the same URL, you're guaranteed to get the same module back both times. And we originally tried to like respect this as a matter of language purity. So we designed assertions this way, but then like, and TCR9 went ahead with this. And like, then we decided, like, we realized that browsers didn't need it. And like tools have been telling us for very long that they want something different. And like, I'm happy that at the end, like TCR9 actually listened to what the community was asking for, and the proposal has been like tweaked. Like the design is very similar, but like something is changed, has been tweaked to better match what the rest of the community needed.
Thank you. Another thing that was really interesting is that you mentioned a number of different module systems, so to say legacy module systems that have existed. For better or for worse, some of them are going to stick around forever, like CommonJS is not going anywhere. Also, you mentioned a number of shortcomings for the new module system. There is a non-trivial amount of people who are upset about the decision to not expand on or like sort of build on top of the existing systems. Why do you feel it was necessary?
Yeah. So like all of this discussion, like TCR9 is not just a closed body where like people don't listen to other people. Like the people working on modules both now, like in this new modules harmony effort, and in modules for ES15 when ECMAScript modules were originally introduced. Like there are people from CommonJS, there are people who work in AMD. So like the result is really trying to like the sum of what all the different like module experiences we had in the past had to say. And like obviously if a system is designed, if a module system is designed to work in some case and you have to design a module system that works in another case, that will be different. And like maybe at the time feedback was not properly listened to. Like I'm not sure what happened because I was not there yet 8 years ago. But like TCR9 is composed of people from all the different backgrounds, like from all these different, like with all these different previous experiences. So we are really like trying to consider all of what we had in the past to build what we'll have in the future.
Thank you. There was a question on the chat. You mentioned at least 6 ongoing proposals. Of course, there's also, there's also a number of additions we've already done to ECMAScript modules and hopefully a few more coming in later. Why is this space so complex and like why is it taking so long for us to figure out how to do modules? Because people have done modules, right?
I think it's complex just because there is like a lot that can be done. Like all languages, well, most languages have modules, and most languages decided something is in scope for a modules implementation, something might not be in scope. But like the scope itself is very large, and it's a matter of like deciding like how you want to cut this very big scope and what you want to keep. And like this doesn't only happen for modules. Like if we think about how JavaScript classes have been standardized, like classes had all like the different areas that had to be taught about, like how should private methods, private fields work in JavaScript. In ES6, we only had these like base classes with only methods. And like, so when scopes are large, it might make sense to focus on the single parts to be able to properly design every single piece like as good as possible. This doesn't always work. Like I made examples of classes. I personally think that it didn't work as well as it could with classes. But like we'll learn from the past, and like just presenting modules as a very big proposal covering everything will be too much. Also because we're not even sure if we want to do everything. So like trying to analyze the complexity of the space in like this, like with all these different like small proposals that can be motivated on their own and develop on their own is the best way we found to cut this very big scope in smaller pieces.
One thing that you mentioned was module expressions and the ability to pass modules around. What about structured serialization of modules? Do you think that's something that's on the horizon?
Yes, so module expressions are developed with the goal of being like serializable so you can pass them around. Structure serialization is not, like, it's technically not defined in the ECMAScript specification. Like when you are developing a proposal like this, you must like know how you think this should be done, like how structural clones should be defined for this. So yes, like I would say module expressions will like likely only move forward if we have like a clear path ahead on how to then send them to workers, because that's why we're working module expressions.
Thank you, that's all.
Okay. I just walked down.
Yeah,
Okay.
pretty much. While we're setting up, I would like to introduce our next speaker. You might be hyped about Kotlin, but I think it's impossible to be hyped about Kotlin more than our next speaker. As far as I've been told, they've been bootstrapping Kotlin compilers for over 10 years and now lead the effort to compile Kotlin to WebAssembly, which is, really important for the web platform, I think. So without further ado, let's welcome, wait, I forgot the, I don't know what the talk is titled, sorry. I can check. That's a very long title. Well, Inside Kotlin WASM by Zalim. So we don't. Okay. Technical. Sorry. Perfect.
1-1. Yeah, nice. Thank you for introduction. Second. Okay. Yeah, so hi everyone. My name is Salim. I'm writing Kotlin in Kotlin at JetBrains for a long time, and now I'm leading Kotlin WASM. Today, we explore some implementation details of Kotlin WASM, and I'm going to show you how we use some new shiny proposals. And I hope it will be interesting and helpful for developers working on WASM VMs or languages targeting WebAssembly. Yeah, before we're going inside, let's quickly look what is Kotlin. Kotlin is a modern statically typed language with garbage collector. It managed to be both concise and expressive. It has a pragmatic mindset while remaining elegant. It has a good balance between imperative and functional features. And one of its key features is null safety, what's turned the billion-dollar mistake, now references to compile time check. So Kotlin targets multiple platforms such as JVM, various native platforms like iOS, Linux, Windows, and so on. Also, we have JavaScript backend and WebAssembly. So you can share code between all these supported platforms, but still you're able to write platform-specific code when it's required. Tooling is mostly JVM based with some integration with platform tools. Kotlin has experimental compiler plugin mechanism for powerful build time transformations. For now, the widest adoption of Kotlin is on mobile. It's officially recommended language for Android. Server-side is another popular use case for Kotlin. Thanks to great Java interop, it could be easily used for any Java. You can easily use any Java JVM libraries and frameworks. Few months ago, we announced Kotlin Wasm as a new experimental target. We built the new compiler from scratch and targeting the next goals. We want to have a fast compilation because we think it's very important to have under the second round trip, and to achieve that we generate binaries directly, and later we're going to make it also incremental. We don't do much optimizations during development builds, but we can use Binarian to optimize release builds. We want to have a good integration with hosts, for example, to avoid leaks with cross-model links. We want to provide convenient and fast interop with host. For example, we provide out-of-the-box declarations for many browser APIs, so you can easily work with any browser API with DOM. And we want to have small binaries. 3 kilobyte is size of Wasm binary with for this example. Modern shiny proposals help us a lot to achieve the most of our goals. We are using following proposals. Oops. Oh, yeah. Second. Sorry. Reference types. Reference types introduces basic reference types and instructions to work with them. It's already part of core specification and implemented by most of VMs. Next is exception handling proposal. As you can guess, it introduces something like exceptions and a way to throw and catch them. It's on phase 3 out of 4, but actually it is available by default in all browsers. Extended name section introduces a dedicated section for storing names for all entities what could have a name in text representation. It's more like debug information. It doesn't affect any semantic of WebAssembly, so it's supported and turned on by default by many tools and browsers. Next, type function references. The name speaks for itself. It adds better typing for function references and the instructions to call functions by reference. It's on phase 3. And last one, but not least, garbage collection proposal. Interestingly, the proposal has only one sentence about garbage collection, but it introduces high-level concepts required for languages and runtimes with garbage collection, such as structures, fields, references, and so on, also in phase 3. By the way, origin trail for WasmGC in Chrome is open for registration. So using it, you can turn on WasmGC for your site. Follow the link for more information. WebAssembly evolves continuously, and there are many new proposals. Some of them are interesting to us, and we are more, even more, we are experimenting with some of them. Let's quickly look at them. There are many proposals aimed to improve interop with external world. Performance is important as well. You can say nowadays disk space is cheap, network is fast, but there is use cases where size is still important, for example, in web. I'd like to highlight few proposals here. First is component model, because I personally think it's important for whole Wasm ecosystem. to get component model ready. Next is multiple memory proposal, because it can unblock some use cases, some interop cases right now without waiting, for example, component model. For example, when we want to interop between models compiled by different languages, so you can somehow manage memory, and without multiple memory, it's tricky, because two languages have to live in one memory space, what is not easy sometimes. And one proposal, what I like is string ref proposal, but I'll explain it about string ref proposal a bit later. Let's take a deep look at some Kotlin WASM implementation details. We start from Kotlin Any. It's base type for everything in Kotlin, like Java Lang object, but better. From Kotlin developer point of view, it has only 3 functions and no fields. But actually, in terms of WASM, it's structured with 4 fields, so every instance of Any has these 4 fields. Vtable field refers on vtable structure for specific class. Now it is any vtable. All instances of any share one instance of this vtable structure with references to specific function implementations. Virtual table used for dispatch virtual calls. Let's introduce another class foo extending any with 1 more field. It was, in WASM, we extend any structure, repeat fields from any, and introduce the new one. We also want to change some method and add a new one. To achieve that, we introduce a new vtable and change the type of original vtable field to a more specific one to avoid casts while we accessing this vtable when we trying to call something from there. In the new vtable, we change the reference to string because we want to provide our own implementation instead of any one, and introduce a new field bar for new method. How to access fields and call methods? Accessing fields is simple. Say we have a local variable d referencing on instance of foo. So we have a stack for values and instructions to execute. First, we need to put reference to the stack using local get. After that, we use struct get to access the field. It takes reference from the stack, read field, and put the value back to the stack. Easy. To do a virtual call, we need a bit more. We have the same variable d with instance of foo, and now we want to call the method bar. We put d on the stack 2 times. First is argument of method itself. The second will be used to reach the method. Next, we read the table field from the instance, then read bar from the table, and finally we can call it using call ref and get result on the stack. Nice. For comparison, a static call of function we know at compile time requires only 1 instruction. Of course, if we need to pass some arguments, we need to push these arguments on the stack before calling. Kotlin also has concept of interfaces. It's much trickier. Let's say the same class foo is implementing interfaces, timer, logger, and maybe something else. So we introduces a new structure, itables1, with fields for each implemented interfaces. For each interface, we have a separate structure, similar of vtables at previous slides, with references to actual implementations. calling interface methods is similar to virtual ones, but need slightly more instructions. Here is comparison of different calls. It gives a good sense of cost of calls, but in real life, it could be a bit unexpected. It doesn't mean what every time virtual calls, for example, 5 times slower than every static call. There is many aspects what could affect your runtime performance. Let's move to string internals. Most real-world applications work with strings a lot, so strings implementation may have a big influence on the performance of the memory usage of application. At the start, we had a simple naive implementation, which is just a wrapper over array of chars, and it's good both in terms of memory footprint and performance, except concatenation. It's a very popular operation over strings. On our side, doing concatenation over default implementation of string is not good practice, and usually languages have some special type to make such concatenations, like string builder in Kotlin. Anyway, it's easy to it is easy to write such a code. It's simpler to write such code and easy to underestimate the hotness of your code. So to optimize the concatenation case, we changed the string representation by adding optional reference to prefix and length. Assume I have 2 strings, hack and fast. If we concatenate them, we will get an object referencing on the left string and share array with data with right one. It could be chained like this until we fold it. It's folded on demand on all other operations. Now it's good in concatenation. Let's go. Next, let's take a look how we transfer strings to JavaScript. Assume we have a string with hi. First, we copy data from the array to linear memory. Next, we could create a JavaScript uint16 array as a view of this required part of memory. And next, we pass this type array to string from char code, which effectively copy data again to get JavaScript string. In real world, in real cases, the string what we want to copy from WASM to JavaScript could be bigger than our buffer. So we repeat these operations, copies, chunk by chunk. Transferring a string from JavaScript is similar. First, we copy data to a linear memory. Next, copy from linear memory to WASM GC array. It's different. And right now, it even worse because we don't have special instructions for copying from memory to WASM GC array or backward, and we just doing it in the loop one by one. After that, after we have copy of data inside WASM GC array, we just use this array as storage inside our Kotlin string. As you can see, we copy twice, and it's far from being fast. We have a plan to rework how we transfer strings. One more little thing about strings, specifically about compile time constant strings. Obviously, we return all strings we know at compile time to store only one unique ones. We store all bytes in data section. It's compact to store. It's we need to generate waste instructions to get this string literal at runtime because GC proposal with GC proposal we have a dedicated instruction to create array from that data section. Also, we have a cache at runtime to share one instance of same string literals within the whole model. Having a special case for waiting one is common trick for languages like Kotlin with UTF-16 strings. We don't have such a specialization yet. The optimization could be applied in general to all strings and help with footprint inside binaries and footprint at runtime. In general, there are big room for improvements in our built-in string, but there is a better option. It is string graph proposal. The preliminary result of our experiments are promising: 60 times faster in interop micro benchmarks and up to 3 times faster on DB monster benchmark, which works a lot with DOM. Okay, let's move out and look at what is already possible to do with Kotlin WASM. So it is Jetpack Compose declarative UI toolkit in Kotlin developed by Google for Android. Some time ago, a team inside JetBrains took it and make it multi-platform, and now you can write and share your UI between Android, Android desktop application, iOS, and web. And on the web, it uses Kotlin WASM. It is a demo originally built for Android, but run inside the browser. You can follow the link on the top and play with live demo. It works smoothly. It shows high frame rate. Yeah, you can see how it's smooth. Also, we working on debug experience, and you can debug it other Kotlin sources, inspect local variables, inspect call stack. Normally it works in Chrome and Firefox nightly. A bit disclaimer, because right now it's broken in the latest Firefox nightly. Yeah, if you revert it in about a few weeks, it will work even in Firefox nightly. Yeah, WebAssembly is great technology, and you know there is a lot of experiments of using WebAssembly outside of browser. We think it has a big potential on server side, specifically Lambda-like cases, Workers, edge computing, and so on. One of example of outside of browser usage is CoWASM. It's a side project of Sebastian Deleuze. Sebastian Deleuze, by the way, is long-time believer of WebAssembly. It's worth to read his posts about WebAssembly. Back to CoWASM. CoWASM is goal of CoWASM is to explore server-side and full-stack development with Kotlin and WebAssembly. It leverages WASI to access to system resources and WebAssembly component model for the interoperability. For now, we deploy CoWASM application to Node.js because we need a runtime that support both WASI, WASM-GC, and a bit of JavaScript. On Kotlin side, we are going to make it possible to run our binaries in VMs without GC. And as soon as WebAssembly runtimes like WASM-Time or WASM-Edge start supporting WASM-GC, we'll be able to target these runtimes and implement HTTP support purely using WASI without any involving JavaScript or Node.js API. Deployment could be target Docker via its WASM support or Kubernetes, cloud, or edge platforms. Combined with capability-based security and microsecond instantiation time, it's going to be a game changer. Let's finish by talking about what's next. I think the general availability of WASM-GC in browser should happen soon, and it's going to be the next big step for both WebAssembly community and Kotlin WASM. About Kotlin WASM, JetBrains is a company creating tools for developers, and we think it's essential having a great developer experience. Compose for Web is primary use case for us now, but we're also excited about outside of browser usages and tools, and looking forward to see WASM-GC support in standalone VMs like WASM Time, WASM Edge, and so on. And that's it. I'm happy to answer your questions, discuss. Thank you.
Hello. Thank you, Salim. Do you want to ask the question, Anne? Wait.
Timo wanted.
Yeah, you can hear me. Yeah, thanks, Salim, for the great talk, and thanks for whole Kotlin WASM team for this experiment. So I have a bunch of questions, so be prepared.
Yep.
Okay, so the first one is about, so when you are talking about calling a virtual method, I know that you're using closed world architecture of Kotlin. So if you know at compile time that this is the only possible method to call in this virtual chain, so have you optimized this in some way?
Yeah, it's possible to make the virtualization. We don't do it ourselves now, but actually Binarian doing for us it's very well. Yeah, it's understands quite good the code we generated, and yeah, in most cases it able to devirtualize our calls.
Yeah, cool. And I know that you're targeting JavaScript too. So how is the comparison between WebAssembly target and JavaScript one?
Good question. So both in terms of performance and size, it's more or less comparable for now at high level, because in terms of time performance, we have a bunch of benchmarks where it shows in some cases what WebAssembly super faster in few magnitudes, but there is still some benchmarks where JavaScript is faster. You know, JavaScript VMs developed a long time, and they're super fast, especially when you say about virtual calls, especially if you say about interface like calls, when you can get different interfaces. In this case, JavaScript VMs super fast. It's very hard to beat. Yeah, but we will try.
Okay, yeah, nice to hear. And also, you've mentioned that I don't know. Does Kotlin have a function with variable numbers of arguments?
From point of view of users, yes, but at runtime it's actually just an array of something.
Ah, yeah. Okay. So when you are calling such method, you are calling it with a reference to array.
Yep.
Yeah. Cool. Yeah. That's all my question. Thanks.
Thank you.
Joel, can you?
So, yeah, I was wondering, you mentioned this microsecond startup time, and there was this post by Fastly people, I think, by various people about how to start up WebAssembly fast based on a snapshot of linear memory. There's a library to do that. Do you have a way to extend that to WASM-GC?
Could you repeat the question?
You mentioned microsecond startup.
No, second, last part. Just
Oh, okay. So the snapshot restoring technique is based on instantiating a linear memory with some fixed contents.
Mm-hmm.
Do you have an idea of how to extend that to WASM-GC?
Oh, actually, it's we don't think about that because it's more something what should be done not our side but on VM sides. I think we can help. We can collaborate on this case. Speaking about microsecond start type. Start time is more, again, more about virtual machines, about how fast they can instantiate their model. We try our best to make as little as possible at start time, and virtual machines like WASM time, they're actually able to instantiate model very quickly in microseconds. And the reason is because they trying to doing things lazily. They try to copy, for example, copy things for data section on demand and something like that. Back to GC proposal, GC languages. Yeah, I think it's definitely possible to make a snapshot and to restore because there is such practice in JVM world. Even you can even do that in some Linux distributions for any process.
Yeah, I'm just curious. I don't see what primitives we have in WebAssembly that would work for that, because you mentioned the data section that works for linear memory, but I don't know how that would work for GC. But
I don't know. WASM-GC, I think, is very high level in this term. You just have a graph of objects in at one time, so you can walk from whole this graph and make snapshot. Why not? Garbage collector actually doing walking from this graph, so you just need to walk again and save bytes somewhere and restore this graph of objects, probably. Timo wanted something to add?
Yeah, I want to comment about your question, Daniel. So actually, our colleague, Andy Wingo, has an idea in his blog post how to make snapshotting and how to support WASM-GC with a Wiser. You're familiar with the snapshotting tool? Oh, yeah. so yeah, he has an idea how to snapshot hold the heap into WebAssembly GC array. So yeah, you can read about it. So yeah, it is definitely possible. Yeah. So yeah, that's my comment. With existing, yeah. Yeah, but we will see. It's just an idea.
Any other question?
Well, I'll ask you a question. First of all, thank you. It was really exciting to know about everything that you're supporting. I was curious how you work with the error handling proposal, and like how does it play into the because I imagine the original exceptions in Kotlin are sort of built keeping in mind the JVM architecture.
Yeah, you mean exception handling proposal?
Yeah.
We actually don't use exception handling proposal very much. We use only a few things from exception handling. It is there is a tag, some abstraction, what you want to throw and catch later. So basically, we use only instructions to mark our code where we want to try and throw and catch something, and we have one tag to throw and catch. So other things, we have many exceptions, and other things we just checking at runtime. We can have a few catch blocks. So we use exception handling proposal to throw at some point and catch in common block, and after that we using instance checks to understand in which catch block in terms of Kotlin we need to go and process. If we don't find any catch block, we just throw this exception. Actually, exception handling allow to do more. You can have more tags, you can more catch blocks. Anyway, even so, this proposal simplifies our code generation because we don't need to make some difficult transformations required to go and find the required catch block through the stack of calls. We just don't think about all this stuff. We just throw somewhere and catch in another place. Everything else is done by virtual machine. Yeah.
And one more thing is, it was really exciting to hear more about WASM-GC and how you work with it. Do you have any idea of like where in the standards process it is, and like when it will likely go to phase 4?
Well, I personally expect it will go to phase 4 this year. Actually, Master of Works is done there. We have one. We have support in Chrome. We have very good support in Firefox already. Right now it's available only in Firefox nightly builds, but they already going to make it available in other builds, betas, and release still under the flag, same as in Chrome. So basically, we have at least two independent implementations in browsers. It is one of important requirement to move to phase 4. There is some support in JavaScript core, what used by Safari, for example. It's not finished yet, so I'm not sure when Safari support will be finished. So tomorrow we have some kind of hackathon to bring this feature where JavaScript core fully support WASM-GC Quasar. So please join us. In short, I think phase 4 this year, and just to say more, also there is standalone VMs what started to support WASM-GC, and it is very nice. There is the WASM Edge what started, and we even managed to run some simple application in Kotlin WASM inside WASM Edge. There is some working started inside WASM time. So it's excited. I think next year we will have already support outside of browser for WASM-GC.
Thank you. Adding to that sort of idea of WASM-GC support, Canada Honk asked on chat if what techniques you use to detect WASM-GC support on an environment.
Sorry.
Like, what techniques do you use to detect if that feature is available? Essentially?
Okay. There is actually library WASM feature detection or something like that, what can detect features around WebAssembly, and you can just take this library. It's under Google at GitHub, and this library already support detecting GC support. In general, technique what used by this library is simple. There is some super simple program in WebAssembly what using feature what you want to check. It trying to verify this binary, and if this library doing it under try-catch, so if this browser doesn't support this feature, it throw WebAssembly compilation exception or something like this, and library catch this and deciding what the feature is not supported. It's easy. It can at some point it can say you what feature is supported, but actually not fully supported, but it is okayish. In case of Kotlin, we also generate simple code what basically doing same things. We're trying to instantiate WASM module inside try-catch, and we catch this exception. And just to help users, we catch this exception, and in this case, we just trying to provide some information like what probably happened, what do you need to do, how you should, what you can do to turn on something in your browser to make it work. Yeah.
Thank you. And finally, what are the compile times like for the JS backend versus the WebAssembly backend? Are they comparable?
I actually don't have such numbers on top of my mind, but my expectation is next. What I think for just a clean build, when you compile everything, it should be close because under hood we use common infrastructure. We share some common overing. Some overings is specifically written for a specific backend, but JavaScript backend already have incremental compilation. So when you change a small part of your application, it can recompile only some subset of your code what affected by your change, not necessarily only one file you changed. Probably it can affect some other files, but anyway, it compiles process less code, so compiles faster. In case of WebAssembly, we're going to support incremental compilation, of course, because, as I say, we want to have under 1 second compilation time in development. Yeah.
Right. Thank you very much.
Thank you.
And thank you for being a great audience. I think we gotta wait like 5 minutes. No, not anymore. Lunch is ready. I'm hungry. Let's go.
Hello, hi. Welcome back. We are starting with our next talk. So we have Jean. He has been at Igalia for 10 years now, and he has been working on WebKit project. He's among one of the people who are behind WP. And today he is going to give an update on WebKit Linux port, WP, and GTK status and plans. So, Jean, to you now.
Thank you very much. Okay, so welcome, another edition of the Hackfest. Stopped count, but yeah, I think they are going for longer than I have been at Igalia. From the very beginning, I've been working on WebKit, kind of kickstarting the WPE port story, and working on it since then, essentially. To explain a bit the talk, is going to be a status report for the WPE and the GDK ports of WebKit. It's going to be high level. I won't go into too many details, especially not on parts where I'm not an expert in. There are probably some things people with the relevant knowledge will be missing. There is nowadays a lot of old guard people here. So apologies for that. There may be unintended errors included there as well. And GPT-free, this is all of my doing of last 2 days. So right, so first a bit about WebKit. It's a web engine with long history. But the neat idea behind it is that there is this common web platform implementation. So essentially different APIs, web-facing APIs. And then there's like, if you want to support WebKit on a given platform, there are many portable bits that you need to provide. And that's the beauty of it. It runs on a very wide range of systems, from Mac and iOS, the two Cocoa platforms, and to most of my interest on Linux. It's also doable on Windows and on PlayStation. This is effectively just a report of today's state of supported platforms. Used to be more in the past, could be more in the future. The three main players or contributors in terms of companies to the WebKit project today are Apple, Igalia, and Sony. And I imagine I'm kind of possibly leaving people out, but there are also other contributors, corporate and private. The two ports, the focus of today's topic are GDK and WPE. As mentioned, they are Linux-based, so everything in today's talk is going to be in the context of the Linux platform. On one side, we have the older GDK, which is oriented towards integration with the GDK toolkit as well as the GNOME environment in general. And then there's the younger sibling WPE, which is a sort of experience to have it integrated and embedded in a desired use case. It's meant for much more lower level adaptation. But because of their relation, there are a lot of commonalities, a lot of common bits between them, the underlying being glib. And then related with that, for instance, libsoup, GStreamer, as well as different other dependencies like Cairo. For GDK, to dip a bit more into that, like I said, if you're working inside a GDK environment and want to provide some sort of web content in there, this is your go-to solution. We support both GDK 3 and GDK 4. GDK4 being a more recent addition, a more recent API release inside the context of the GDK toolkit. It also integrates very well with different other GNOME components. For instance, the accessibility toolkit and password management. So effectively, when under GNOME, use GDK. And WPE can be thought of like the GDK port without the GDK toolkit integration. It sort of started that way. Like said, there's this lower level integration approach that has to be done when using it. And that makes it very flexible, very adaptable to many different use cases, as long as there are certain conditions fulfilled in terms of underlying platform support. Since GDK is removed, there is effectively no toolkit, and that can harm us in certain cases, but in other cases it's also a feature. We have seen kind of situations where a toolkit is either or both not necessary as well as not desired, and WPE fits there really well. All of that makes it very flexible and also minimal, but again a bit harder to integrate. As such, it's very much meant for embedded devices and systems. Should be mentioned here, we've also recently had an effort of bringing up WPE on Android. This has been blocked about before, but we've recently had another iteration of effort on that part, and the desire was to present something here in the Hackfest. Unfortunately, Yanni and Loic, fellow Gallians who have been working on this, have not been able to kind of have a presentation ready about this topic. So hopefully next time. To explain the commonalities, there's a large part that is shared in the graphics stack, as well as related to this, the multimedia integration, multimedia being effectively done through GStreamer. We also share the networking implementation, which is based on libsoup. And then, of course, there are different web standards implementations that we most often share, especially when there are like separate dependencies that we have to include. We are able to have both ports work with the same implementation. We have the release processes aligned between the two ports, which means that we align the release scheduling as well as the branching mechanisms. And the current stable series is 2.40. There's also development tooling we use around both ports, and that is shared, I think, in large majority between the two. Shortly about the differences today. There are certain details in the graphics stack. For instance, GDK has different ways of implementing cross-process management around graphics concepts. And WPE only has one way because of underlying implementation and design. And of course, the biggest one is that with the GDK port, there's the GDK toolkit, which we can depend on, and WPE does not have that for better or for worse, depends. But for instance, just because of that toolkit presence, the GDK port is able to support things like color picking widgets, things like that, which is not impossible for WPE, but it gets harder quite quickly. So this next part goes through different sections and the state of them. A lot of things here are common between the two ports. Effectively, all of them are. So first off, graphics. Recent developments here have been angle support, which through which we benefit immediately with better WebGL conformance as well as WebGL 2 support, and as well as initial GPU process support. That is for now used only for WebGL execution. It's also somewhat experimental, but in progress. Both of these are based on DMA buff. DMA buff is effectively Linux-specific buffer management mechanism, which I go a bit into more detail later, and if necessary, much more detail tomorrow in the breakout session in the morning. On the multimedia side, as mentioned, GStreamer is the library that we use. MSC and EME behavior implementation, those two are effectively our bread and butter. So they perform reasonably well on a given Linux system, and much better even on embedded systems that we have to pay special attention to. We've made certain progress with WebRTC, which today is based on GST WebRTC, a relatively new and progressing plugin inside the GStreamer ecosystem. Then there's standard support like media capture, media stream, and media recorder. Over the last year, there's also been work on experimental web codec support. And again, the DMA buff support, which here is basically utilizing different GStreamer decoders that yield us DMA buff objects which we can handle somewhat more adaptable and efficiently than what the default pipeline does today. Shortly on networking, we have kind of taken over development of libsoup, and through that, the libsoup 3 API release has been made. API had to be changed in order to bring support for HTTP2 and other networking standards, which we were lacking behind on. For now, we are still supporting libsoup 2, so kind of supporting both in parallel at the moment. And on JavaScript core, again, bread and butter, the 32-bit ARM and MIPS support. For those two, we have basic JIT tiers up and running and supported. And for ARM specifically, we're also progressing on WebAssembly support. There's also initial RISC-V support for again, the basic JIT tier. And for every other platform, especially if it's 64 bits, it should be up and running pretty well. So effectively no issues there. We're happy to kind of handle those alongside Apple and Sony, which are privileged to work only with 64-bit platforms. And this is the second part of the presentation. It goes effectively through same sections, but presents the plans for the future. For the two ports, in general, the desire is effectively to have as much alignment as possible, meaning eliminating differences where possible. And the desire has always been that since WPE was kind of spawned by taking GDK out of GDK, to have instead WPE and then GDK working on top of it somehow, just by the addition of the GDK toolkit support. That was somewhat naive, and the desire would be to possibly in the future rework and refactor things to make that possibly more achievable and could be done with future changes, especially in the graphics stack. But for now, we're just trying to eliminate differences as much as possible. We hope to continue, effectively intend to continue stable releases from the common branches, because it's just a pleasure to having only manage the single branch and apply security fixes and later commits only in one place and have both ports benefit off of it. We're also working on some simplifications around how WPE can be used and integrated. Right now, like I mentioned before, while it's adaptable, it's also somewhat painful to work with. And we want to kind of ease that to make it simpler. So we'll try to provide some some good but essentially basic support for different platforms to make things more plug and play for very simple use cases. On the graphics side, this will probably be discussed more tomorrow, but changes in the WebKit architecture, as welcome as they are forcing our hands a bit in terms of how things move across different processes. GPU process could be used for 2D painting and will be used for WebGL and in the future WebGPU execution. It's essentially a fact at this point, so we need to get prepared for that and have things in order and functional. There's also, since we're moving things around, the possibility then to also move around the composition step. Right now it's done in the web process, which is not ideal, but it's the easiest to implement. But it's also not performant or not ideal because we would like to have better, for instance, gesture handling. And it gets painful real quick when that gesture handling has to cross multiple process boundaries. So one proposal, the ideal solution, I believe, would be to do that in the UI process, which is, for instance, how the at least variants of Mac ports do it right now. That needs kind of a bigger revolution around our own graphics stack that we have to kind of lay out and understand the consequences as well as the necessary steps in implementation. All this imposes a requirement on us, which is the cross-process buffer sharing. I've used this phrase over the past 10 years a lot, and it's kind of was always wrapped around different mediocre solutions, especially in the context of the mainline Linux stack. Things have evolved over the past few years to the point that DMA buffs are entirely usable for this use case. But again, this is limited to the very vanilla Linux systems and the graphics stack, which means your recent Linux kernel and ideally the Mesa graphics library. Well, that's great, but we also have a wide range of other platforms that we want to run on, and we don't really want to sacrifice functionality or benefits of these improvements that we are planning. So the desire and I suppose obligation is to go platform by platform and find a solution to these issues. So the breakout session tomorrow is intended for that. We have a good understanding of many Linux graphics platforms. We do not have a necessary understanding of all of them, or at least the ones that other people, other users of WP and GDK have an interest in as well. So tomorrow the plan is to provide an outline of what a solution based on DMA buff would be, how it would work, how we are planning to implement it, how different parts are involved in this, how WebGL, WebGPU, 2D painting, how it all, and composition, wherever it's done, how this falls into all of it. So we have our plan, but if there are other people here who have like an interest in this, we would also like to hear what they are thinking about. And of course, nothing's going to be decided tomorrow. We would just like to hear first thoughts, or at least provide our own in public. The plan is to kind of have a discussion then outside of these forums, meaning outside of the Hackfest, just through, I suppose, an initial blog post and then various discussions in different venues, just for us to avoid making steps that, or writing checks that other people won't be able to cash on their platforms when using WPE or GDK. So tomorrow morning, yeah, welcome. So for the other remaining sections on the multimedia, basically this is continued work. EME and MSc, at least in my experience, are kind of always throwing curves at you. But in terms of the fun stuff, WebRTC and WebCodecs is something that we are going to hopefully push things through, to have something stable, something releasable. And the long tentacles of WebKit graphics also extend here. The GPU process is effectively meant for media playback as well, and not just playback, but also encoding of different video input. So the desire is effectively to move everything that touches the GPU or different hardware decoding devices to push it into the GPU process and sandboxing. So it has far-reaching consequences just to support that. And just for JavaScript core, finally, 32-bit platforms, for now, I believe those are staying. But we can't commit to much more than supporting the baseline JIT as well as LLint-based WebAssembly. But also general WebAssembly on other platforms, and where needed to adapt the behavior functionality to the Linux platform. That is also something that we would really want to support in the future. So that was very brief, and thank you very much. Now, if you have any questions, please.
Thank you very much, and very, very interesting presentation. Do we have questions?
It works, right? Yeah, so thank you for the presentation. I had one question, maybe mostly out of curiosity. On the slide 6, you mentioned that WP doesn't have, on some platforms, don't have a toolkit.
Yeah.
So the question is, what exactly does the toolkit provide to the WP? So I imagine that it's mostly the integration with the environment, right? Or does it have something else?
Integration with the environment, and it depends on your level of embedding. WPE excels when you effectively only care about web content and want to have a flexible way to integrate it into your display system or application. Now, it depends whether you just need a single window of it with limited controls or other widgets, or whether you want to embed it into like some corporate application that you have to also embellish with, I don't know, different other functionality. In that case, it can be lacking quite quickly. Whereas if you are basing your application on GDK, GDK the toolkit, then you, with the GDK, the WebKit port, you basically get a GDK widget that you can integrate in your application as any other widget. And that's the flexibility that the GDK integration provides first and foremost. And subsequently, just behavior under a GNOME environment is much more natural than what you would get with WPE, which doesn't really care where you run it, as long as you don't expect like this pitch perfect integration.
Yeah, all right, thank you.
Well, do we have more questions?
Jan, what is going to happen with the platform that they lack DMA buff?
What about them?
With the DMA buff, because not every driver, graphic driver, can provide you DMA buff.
Yeah.
What is going to happen in that case? What is going to be the plan for WP?
So that's what we want to know. Which are those platforms, and what is possible on them? Not in terms of DMA buff, but in terms of what those platforms provide in functionality that effectively is equivalent to DMA buffs. We're not really afraid to touch something that we don't know, but we need to get to know it, to understand how it works, and then add support for that upstream. We're totally fine with that. It's something that has to be done. But first and foremost, the platforms need to provide a way to do that. And ideally, it would be a way that is efficient, meaning that everything stays on GPU, because what we can commit to is effectively providing software fallbacks. And that's going to work, but it's going to be slow. So the DMA buffs that we are planning to use as reference implementations, it's accessible through file descriptors. There's good support in the graphics libraries for different operations that we need, meaning that we can take a DMA buff and render into it, and then take that file descriptor and just move it over to a different process and handle it there. This is, in short, the behavior that we need. And it's something that is achievable on other platforms, not necessarily through DMA buffs. For instance, on Android, we didn't yet implement it, but we have it pretty well sorted out, that you have this native hardware buffer that you can use in very similar fashion to how DMA buffs are used, but it's just different interface. So it has to be, ideally the platform supports that. There's documentation about it, that we can learn about it and have the support implemented and working. Like I said, not afraid of that, but the platform needs to enable that kind of behavior for us to leverage it, just to get all this up and running.
Okay, more questions? Okay, then I have a question for you. When you were talking about Android there, you mentioned that there has been an effort to bring WP to Android, and you mentioned that there has been blocker as well. Can you tell us more about what kind of blocker you were referring to?
So the effort actually has been ongoing, not ongoing, but started like a few years ago. I put together a quick concept and was showing it to people. So inside Igalia, we pushed this a bit forward and decided that, okay, let's try and get media playback working on it. And unfortunately, I don't recall the name of the person. He left Igalia, unfortunately. But there was a blog post explaining a bit what is going on, how it's done. And it's been a few years since that, and only lately, last year, we've picked this up again. Again, just refreshing things, fixing problems as we found them. And certain amount of focus was again spent on media playback. So I cannot give you an exact date or title of the blog post, but I think it's somewhere on Igalia's website.
No worries, I think I can check out later. Thank
Sure.
you. Thank you very much.
Thank you.
All right. Next, we have talk from Dylan. Unfortunately, she's not here, but Dylan has been at Igalia for 2 years. She has worked on Blink, and starting this year, she joined Servo project to help with the renewed effort on the project. Other than that, Dylan is also speedrunner and tinkers with Olsen workstation in her spare time. If you are curious about browser engines and browser in general, you should definitely check out Dylan's GitHub. She has been building her own toy engine as well. And today she will be talking about the work we have done this year on Servo and plans. What are the plans for Servo in 2023? So, yeah.
Servo is a web engine started in 2012 by Mozilla as a research project. In the 8 years since, Servo has been a vehicle for 3 main things. Servo heavily influenced the Rust programming language, especially leading up to Rust 1.0 in 2015. Servo was also a great place to experiment with parallelism in web engines, which gave us things like work stealing in the style engine. Finally, Mozilla took those lessons they learned from Servo back to Firefox. So the DOM subsystem now runs on user space threads with cooperative scheduling. And several Rust components like encoding RS, stylo, and WebRender were integrated directly into Firefox. By mid-2020, this oxidation effort reached a point where over 12% of the Firefox codebase was written in Rust. And then the layoffs happened. By this point, the WhatWG encoding library, that is encoding RS, the CSS parser, the style engine, or stylo, and graphics renderer, or WebRender, were now part of Firefox. And for some of these, Mozilla Central is actually the upstream now. Servo also borrows its JavaScript engine from Firefox in the form of SpiderMonkey. But this whole time, Servo has been this more or less independent web engine written almost entirely in Rust. It has parallelism in both style and layout. It was designed for modularity right from the beginning, and it was also designed to allow for embedding, although there's a fair bit of work still needed before that will become practical. What can we do with that? What new purposes can Servo bring to the table? With the help of the Linux Foundation, we've managed to secure some funding to start working on Servo again, and our initial focus is going to be embedded. Why embedded? Well, I think we can all agree that we need more web engine diversity, and that includes diversity in general purpose browser engines. But taking on Google, Apple, and Mozilla isn't something we can do overnight. Certainly not with the 5 or 6 people we have working on it full time right now. On the other hand, the embedded web engine space is even less diverse. There's WPE, which runs on WebKit, and CEF, which runs on Chromium. And those are pretty much your only major options. Embedded web engines also allow for use cases where the content is written by the same people who want to embed the engine, which means the content can sometimes be tailored to the features currently supported by the engine. At the end of the day, focusing on embedded means Servo can reach a useful state sooner. This includes many improvements to builds and releases and making it easier to contribute to Servo, several big dependency updates. We've put a lot of work into reducing web platform test failures, and in particular, flaky tests. There's been some new feature work as well in Layout 2020, which is the newer of the two layout engines. And we're going to come back to these in a bit more detail soon, but keep an eye out for the non-Igalia contributors in bold. The Technical Steering Committee oversees pretty much everything Servo, including committers and other roles, the design and architecture of Servo, builds and releases, and outreach. We now meet monthly, and the exact dates and times are announced on Zulip. That said, you don't need to be on the committee to participate. Anyone can raise points to discuss on GitHub, and the minutes are published live on Zulip and later on GitHub as well. I mentioned earlier that Servo currently has two layout engines. One of them is currently known as Layout 2013, and it's still the default for now. There's also a newer layout engine designed to replace Layout 2013, which was still a work in progress when development stalled. This newer engine is known as Layout 2020, though I suppose, given the delays in switching to it, 2020 is a bit of a misnomer at this point. So, to be clear, layout in Servo covers everything between DOM and style and the display list, including what some engines, like Chromium, call paint. There are several differences between Layout 2013 and Layout 2020, but here are the most important ones. The main drawback of Layout 2020 at the moment is that it's not as complete as 2013 is. So, most importantly, it does not yet support floats, tables, or incremental layout. On the other hand, Layout 2020 uses opportunistic parallelism, which is an improvement over the eager parallelism of Layout 2013. You can think of this like opt-in parallelism versus opt-out parallelism. The approach that Layout 2013 used unfortunately made things like floats and margin collapsing a bit of a nightmare to implement and maintain. Perhaps surprisingly though, the performance of opportunistic parallelism is not generally worse than in Layout 2013. It's about the same actually, and in many cases the performance is better. Layout 2020 also splits the flow tree into separate box and fragment trees. This should improve the implementation of fragmentation and multi-column layout. Layout 2020 also generates a web render display list directly, rather than having to go through an intermediate representation like Layout 2013 does. And finally, Layout 2020 is more closely aligned with web platform specs in its naming and architecture, especially with CSS specs. We're hoping that this last difference will make Layout 2020 easier to contribute to as well. Based on these differences, we proposed a gradual transition to Layout 2020. This will involve a handful of steps, but the first two of these steps are already well underway. We're going to improve support for Layout 2020 in CI and releases, and we'll also start implementing some smaller features like text indent and vertical align, just to get a feel for what it's like to develop for Layout 2020. Eventually, we'll need to decide if we want to remove Layout 2013 and commit to the switch. And assuming we go ahead with the switch to Layout 2020, we'll hopefully be well placed to tackle the most complex features of CSS2, like floats. If you're interested in some of the details, check out our report, which I've linked in the slides. When we run the web platform tests, we now retry unexpected results to iron out random flakes. We also now have support for marking tests as having multiple acceptable expectations, such as a test that can either pass or fail, or a test that could pass or time out. My colleague Martin has fixed a bunch of sources of flakiness in Servo, in particular in scrolling, hit testing, and animations. I've helped land a long-standing change that adds named access on the window object to Servo. This is a web platform feature that hundreds of tests rely on that allows you to look up elements by their ID implicitly as properties on the window object. And we're also working on support for the font loading API, which will help with a lot of tests that rely on web fonts. In our builds and releases, we now have comments on our pull requests after each build that summarize the test results. We've also built a new intermittence dashboard, which will help us analyze the causes of flaky tests. We've made several improvements to builds in forks and web platform test upstreaming. Sagudev has also contributed a new mark try command and also support for SC cache on Linux and macOS, which should improve CI times on those platforms significantly. We've helped land a whole bunch of dependency updates, most notably in the TrueType, Winit, and Euclid crates, in our Python and Rust tooling, in webidl.py, as well as several crate dedupes, which should make the build faster and smaller. We're also working on a WebRender upgrade. In Layout 2020, we've added support for the new layout engine to Mark, and partial support to CI. We've added support for frames, the min and max width properties, and the min and max height properties. We've also added support for text indent, outline, and outline offset, and we've even made some improvements to text decoration. Coming up in Layout 2020, we will probably take a look at position sticky, the vertical align and whitespace properties, counters for ordered lists, and eventually the boss fight of CSS2, floats. There are a couple of ways you can see Servo's web API support. One of them is wpt.fyi, which actually has data for Servo, it's just not shown by default. To fix that, click Edit, Add Product, then choose Servo and click Submit. FYI is great for drilling down from specs to directories to tests and subtests, but it's not so great for tracking progress over time, though that is still possible. Note that the data here is currently for Layout 2013 only, but we're going to add Layout 2020 soon. We've also created our own web platform tests dashboard. This page tracks our pass rate over time, has nightly data for both Layout 2013 and 2020, and it even has filters for our various focus areas, including key sections of CSS2, the CSS object model, and the CSS position module. To understand how Layout 2020 currently compares to Layout 2013, let's take a look at ACID 1 and ACID 2. These tests already passed in Layout 2013, but don't yet pass in Layout 2020, and looking at the results may help us understand where we're at with the feature set. So ACID 1 is more or less correct, with the exception of a complete lack of float support. And ACID 1 relies on floats heavily, so all of the boxes are stacked on top of each other. As for ACID 2, well, the results are a bit more gnarly, but having an understanding of what isn't yet implemented in Layout 2020 means that the result is actually quite understandable. For one, there's no support for floats yet, there's no support for whitespace other than normal, or vertical align values other than top. The only list styles supported are inside and either disk or none, and tables are unsupported, so the unordered list and list item elements can't have their display values set to table or table cell. There's no support for object tags in 2020 yet, and there's some keywords in the background shorthand that are not yet supported. So if we applied those styles for things that are not yet supported to the ACID test and loaded it up in, say, Firefox, we'd get basically the same result as we do with the real test in Layout 2020. The ACID tests aren't everything though, and there's still a lot that you can build that runs on the features supported by Layout 2020 today. One of Servo's classic demos is the Mosaic Gallery, which stresses our parallel style system by using elements with CSS transitions as pixels. A new demo we're especially proud of is the Twiggle Tunnel, which relies on our fairly robust WebGL support. And to top it all off, these slides that you're looking at in this talk are rendered entirely in Layout 2020 as it stands today. If you'd like to get involved with Servo, check out our Hacking Quick Start Guide, join the Zulip if you have any questions, hack on Layout if you dare, but maybe after we switch to Layout 2020. Definitely hack on other parts of Servo as well though, especially the DOM, CSS object model, navigation, iframes, and dev tools. Did you know that Servo has support for the Firefox DevTools protocol? Unfortunately, it has bit rotted to the point where it no longer works, but if you can fix that, we would much appreciate it. Join us and make some cool demos that show off Servo's capabilities on Servo experiments, and be sure to report any bugs you find on GitHub. You can find these slides at go.daz.cat/JTHHA. Thanks a lot.
We have Dylan joining us live. Let's see if we can do it. Oh, yeah. Hey. So do we have questions? Hi, Dylan. Can you hear us?
Yes.
Okay,
Am I coming?
cool. Questions, anyone? Okay, no worries. Then I have questions for you. So you mentioned Layout 2013 and Layout 2020, and we can also see lots of messages regarding that on metrics. So what is the status of transition now?
Transitions, sorry?
What is the status of Layout 2020 transition now?
Oh, I'll share my screen actually, because a couple of things have happened since I wrote that talk. The two big ones are, is my screen coming through okay?
Yeah.
Sweet. So the two big ones that have happened since I wrote the talk are that at the last TSC meeting, which was about a week ago, we decided to switch the default layout engine to Layout 2020. We haven't actually done that yet, but that's going to mean that when you compile it from source, it's going to default to Layout 2020, and also the releases that you download from the Servo website will start using Layout 2020 soon. And the other thing that's happened recently is that we've started working on floats now, and we've landed an initial patch that like partially implements floats. But yeah.
Cool, thanks. We have a question on metrics. How far is a pure servo browser for daily end users usage on desktop away?
It's probably a while. There are a few things that are missing that before you could use Servo as a daily driver. One is that there's no real UI to it, which you'll probably see soon. If you tried Servo now, there's no like address bar or anything like that. Context menus, input is kind of limited. But the bigger problem is that using Servo as a general purpose browser won't work for a lot of modern content that relies on stuff beyond CSS2. The JavaScript's okay, but it'll be a while before you can use Servo as a sort of general purpose like daily driver.
Nice, cool. As you were talking, you mentioned that there is no UI on Servo right now. So how did you run the Servo experiments?
Yeah, so if you want to use Layout 2020, you can't use the pre-built versions of the Servo website yet, although we'll be switching that over soon. So for Layout 2020, I'm going to build from source. It's like a thing in the way. So build it. should already be built. And demo.servo.org. So yeah, pass in demo.servo.org, and this should be wrapping. I'm not sure why that isn't wrapping. There we go. So you can pick a demo, and oops, sorry. And at the moment, if you want to go back, you'll have to hold Alt or Option and press the left arrow, because there is no like UI yet. We should probably like add some links, like a button in the corner or something. But yeah.
Cool, very cool. Thank you. One last question from my side. You mentioned that there wasn't any support to float when you recorded this presentation. So how did you get the images to float?
Yeah, so I, for most of them, I used inline block, aligned everything to the top, and just had like widths. For one of them where the text appears to wrap around the image, where is it? I've just used like absolute positioning and had it overlap. There's actually like a bunch of interesting workarounds. Like if you pull up the slides, you'll find a bunch of interesting things I had to do to to make it work well in Servo. But yeah.
Cool, thank you. We have one more question on metrics. How do you see the future of Gecko and Servo?
I think I can't really speak for Gecko, but I think the relationship between Gecko and Servo will continue as it has now. Like there are some major components of Servo that are shared with Gecko, and I don't really see that changing. But like on the Gecko side of things, I can't really speak for that. You'll have to ask some Mozilla folks.
Do we have some Mozilla folks here who would like to answer, maybe? Oh, yeah, Emilio.
Yeah, I mean, I'm all for not duplicating work. So, like, especially as Servo matures and more people start, like, fixing bugs and stuff, it would be great to be able to both, like, share our fixes so you don't have to implement, like, the style engine, like all the new style engine features that we've implemented since 2020, and vice versa as well. So, yeah.
Thank you. All right, let me check again, Matrix, if we have any questions. Okay, no questions. Any questions from here? Okay, no questions. Thank you, Dylan. Thank you very much.
Thanks.
All right. We have next talk from Andreas. Do I see? Oh, he's there. Okay, so while Andreas is walking towards the stage, let me introduce him to you. Andreas has been in browser ecosystem since 2006. First on KHTML for fun, then WebKit at Apple professionally for many years. And since 2018, he has been developing a new OS from scratch, Serenity OS, which has now a big community of contributors. They have started to work on a new web browser, Ladybird, and rendering engine, LidWeb, on last years. Andreas has also have a pretty much popular YouTube channel. If you want to watch him code, you should check that out. And today he will be talking about his project and how things have been going. So Andreas, to you now.
Oh, hello. Okay, great. Let me actually hook this up. Oh, by the way, I should introduce myself and say, well, hello, friends, if you are familiar with my YouTube channel. Let's see. Okay, yeah, thank you. That's all good. Yeah. Okay. I just need to give me some volume, I think. And now I can be heard? Perfect. All right. Sorry for the technical trickery. Right. I'm here to talk about Ladybird, and let's see how to do that. That's how you do that. Okay. Hi. I'm Andreas Kling. I've been in the browser industry for a long time, since 2006, as she mentioned. Made my way through various projects and companies. And nowadays, since 2019, we are working on a new novel engine, which I'm here to talk about. So let me give you a very quick high-level overview. Ladybird is a full-stack browser and engine. So we don't take any code from existing projects. It's our own JavaScript engine, our own CSS implementation, everything from scratch. And it's permissively licensed under a 2-clause BSD license. So if anybody sees anything they like and they want to use it for something, just go ahead. Do whatever you want. Just keep the license thing at the top. And it's written in modern C++, which is perhaps not the language I would have chosen today, but the next point explains what happened. So it's part of the greater Serenity OS project, which is an operating system I started building in 2018 as kind of a hobby personal therapy project after I completed a drug rehab program. And I just wanted something to pass the time. And then it accidentally became a huge project, including a web browser. So that's sort of where it came from. But today we have the cross-platform browser component, which sort of spawned out of Serenity OS. And it runs on Serenity OS, of course, but also on Linux, Mac OS, and almost any other Unix-like system can run it with a handful of tweaks. It doesn't run on Windows yet. Every now and then somebody shows up and says they're going to make it run on Windows. Nobody has taken it all the way, but one day somebody will. The project goals for Ladybird, it's tricky because everybody who works on a project like this, they come with their own goals and their own dreams and desires. But my personal goals are that it wants to render the live web with an acceptable level of stability, security, and performance. So basically be like a usable browser on the desktop, and maybe even on mobile, that can display the web, like the real web, not just test pages at home, but like download stuff and show you. And we also want to advance the web platform by being good citizens and filing spec bugs, fixing spec stuff that we think we know how to fix, and writing tests when that's necessary, and also filing bugs against other browsers, because one of the things that we end up doing a lot is just testing what happens if I load this test in another browser? What did they do? And then sometimes we discover inconsistencies, and we want to be, good boys and girls and file issues about that. And like the Servo folks mentioned, we want to add engine diversity to the market as well. I think we are living in a slightly sad time where big companies like Microsoft and Opera just kind of give up on building their own engines, and it's up to hackers like us to make new ones. And of course, the fourth and arguably the most important goal is to have fun, which we are having just so much of because this is off the hook. All right, next up, let me just give you a quick overview of the timeline of what happened. So in June of 2019, I was just working on Serenity OS with its little GUI, and I was thinking, you know, it would be nice to have a rich text display widget, so I could display not just like one single font of text, but maybe like bold sometimes or different font sizes. And I thought, well, what would be a good internal representation for rich text? Maybe HTML. So I made a simple thing for that. It was fun to hack on, so kept doing it and kept adding like little things that eventually you could kind of tell that, okay, this is maybe more than just a rich text widget. So in October of the same year, I added a browser application. So like a simple GUI app called Browser. So it was now actually a browser. But even then, I was still thinking, oh, this is for like displaying local HTML files and documentation and stuff like that. We're probably not going to do JavaScript. And of course, in March, I decided to do JavaScript. So I made a video actually on YouTube of just starting a JavaScript engine from scratch. And a lot of people watched that. And some people thought, hey, wait a minute, I can do this. So they started helping out. And because of that, it accelerated super fast. And we got the initial implementation of JavaScript went way faster than I expected. People added all kinds of like different operations and the runtime functionality needed, and then somebody came and wrote a parser, which made the whole thing take off really well. Anyway, 3 months after that, I thought, you know, it's pretty annoying that this thing keeps crashing like the whole window when I just have some bug in a page. So we should probably be multi-process. So I did that as well. That's still the architecture we have today. Sort of, it's a process per tab. It's not the most mature architecture, but it's where we're at. And then after that was like a big 2-year gap where we didn't really have any huge milestones, but rather just incremental improvement, tons and tons of small milestones and medium milestones, but nothing big and juicy until July in 2022, when I added a cross-platform version with a cute GUI. And what happened there was that this whole time, until then, we could only run on Serenity OS. So we were kind of confined to running inside of a virtual machine, running on our own operating system. And then in the start of 2022, somebody named Dex went and did the grunt work of making a Linux port of the web stack. And then I built on top of that to make an actual GUI for the browser. And that is what is the Ladybird cross-platform thing today. Anyways, that's the rough timeline, just to give you an idea. Let's talk about the current state of Ladybird. So Delan mentioned acid tests. So this is us on the acid tests. We're doing pretty OK. Now, I'm cheating a little bit here because they're pretty small pictures. So you can't see. There's a little deformity on the acid 2 man's chin. He has like a slice of red. It's not so important. And also, there's a little flakiness on acid 3, just to be totally honest. Sometimes you have to reload the page to get a full 100. But we'll figure that out eventually. Now, the acid tests are, of course, they're pretty old, right? I think acid 3 was last updated in 2011 or 2010, something like that. So we are making progress on modern sites as well, such as the site for this event, which we recently spent 2 days just making work. So I could have this slide. But yeah, so we have a decently mature Flexbox and less mature, but up and coming grid layout implementation. And we keep improving and improving by just taking live websites and trying to get them to work and look good. But many bugs remain, of course. This is very often what you would end up seeing. Like, it kind of loads, you can recognize the page, but there's something like a goof. And many pages don't load at all. I don't know why I chose this specific example, but many bugs remain, and we are working on that. So I said I would also give a brief overview of the architecture of Ladybird. So let's do that. here is the rough idea. So there's a process boundary, as you can see. On top, we have sort of the UI, the GUI process, which is the thing you interact with your mouse or touchpad. And we have two separate GUI applications, one written for Serenity OS and one written for Qt. This is not ideal, and we would love to have a single application. It's just the way things are right now. They are written in slightly different ways, so we can't share the code yet. Anyway, those two things are fairly small. It's like less than 4,000 lines, I think, in the applications. Everything else is shared. So we have libWebView, which provides a web view. And then on the other side of the process boundary, we speak via an IPC link to a web content process, which is sort of the rendering process. And it has all of these cool libraries inside of it. And all of them are homegrown from the Serenity OS project. And I'm going to tell you a little bit about our different libraries. So we have libjs, which is our implementation of ECMAScript, language and runtime. And it also has a garbage collector, of course, because you need one for JavaScript. Execution is done with a simple AST tree walk interpreter, so it is very slow. And it has all of the typical like AST tree walk interpreter problems, like you can run out of stack if you recurse too deep and stuff like that. So we are working on a bytecode VM, but it's not as good as the AST version just yet. The whole libjs is almost entirely unoptimized. So for anybody who's interested in optimizing JavaScript engines, there is a tree here with like all low-hanging fruit. Just saying. And we also have libweb, which implements most of the web platform stuff. So DOM, HTML, CSS, SVG, fetch, XHR, other stuff like sub-resource integrity or UI events, like any kind of web spec, it usually just goes into libweb. And it's also responsible for layout, painting, and hit testing. Maybe I should have put event handling on this slide. But yeah, it does kind of what you would think it does. It implements the web platform. And then we have all these other libraries. So I'm not necessarily going to talk in depth about any of them, just to give you an idea of all of the different components we have, because we make all these things ourselves. And all of this stuff is in our repository. It's all part of a monorepo. And these components are used not only in our browser, but also in the Serenity OS operating system. So they have sort of a dual purpose in that sense. All right. Next, I guess I wanted to give you just a quick look at the class hierarchy that we're working with, because at least this is something I always look at when I want to look at another browser engine and see how they do stuff. I'm always curious, like, what is a DOM node in your engine? In our engine, it is a JS cell at the root. So a JS cell is just a single smallest unit that you can ask the garbage collector for. So it's just a garbage collected object. And then what you see there is sort of, if you're familiar with the web specs, you would recognize that inheritance diagram. We've modeled kind of the exact diagram from the IDL. And this is a theme in our engines, by the way. We try to model the specs as closely as possible for multiple reasons, but my favorite one being that it just makes the code so much more maintainable and approachable for new people, because if somebody comes to us and they've never looked at our code, but they're familiar with the specs, they'll recognize everything because it has the same names, follows the same flow, everything, even the variables and function names are the same as the spec. Right, so last thing I wanted to mention here, as you can see, we do garbage collect our DOM. And this is something when I worked on WebKit back in the day that always irritated me, that they have this dual setup where you have reference counting and garbage collection, and sometimes objects with one ownership model owns objects with the other ownership model, and it's just a big mess. And I always wanted to change that in WebKit, but I never had the energy to go through with it. But here, I did, and it was a great personal achievement. Anyway. That was a little nerdy. Let's look at the next slide. So this is our very high-level rough rendering pipeline For anybody who's familiar with browsers, you probably know this stuff already, but just a quick overview. We combine the HTML DOM and the CSS OM into per element computed style. And then we build a layout tree out of that, or a box tree, as they call it in the CSS specs. And then the layout tree is what we run the layout algorithms on, which produces a paint tree. And the paint tree is just the final thing that you can draw into a bitmap or a window or onto a printer page one day, maybe. So the final state of this machine is like a tree that has just absolute coordinates for everything, and it's ready for painting and ready for hit testing. Right, this slide. Our layout implementation, I wanted to just talk about it briefly because it's another thing I think is interesting, and I always look at how other engines do layout. Ours is organized around CSS spec concepts. So we have a formatting context base class, and then subclasses for the block, flex, grid, table, and so on, all the different formatting contexts. And we have a concept called available space, which maps to the same concept from the CSS sizing spec. And the inputs to layout is typically you make a formatting context, and then you tell it which box to format and how much available space there is. And then it will figure out the rest. And that has made layout quite easy to work on, which I'm really happy with. And we have two layout modes that you can run these formatting contexts in. There's normal layout, which is what we do most of the time. And then there's intrinsic sizing, when we're just trying to figure out how big is an element if it's unconstrained by context. And they're almost exactly the same. It's just that when we do intrinsic sizing, we can avoid some stuff. Like if something has like specific size specified by CSS already, you don't necessarily need to look inside of it to figure out how big the children are, because you're only interested in the outer size of the thing. Anyway, how do we test all this stuff? Well, for libjs, we have an in-house regression test suite, which we've just kind of been accumulating since we started building the JavaScript engine. So those are tests that we make for ourselves whenever we find stupid bugs, and we make stupid tests. But we also run test262, so we have a test runner for that, and we run those on every push to our master branch. So we track them in a graph, and the graph has been hugely successful. Made a lot of people really interested in improving the graph. So looking forward to adding more graphs, by the way. For WASM, we have a test WASM tool, which just gets the WASM spec tests and runs all of those. And for libweb, to be honest, we were not testing libweb very hard for a long time. It's only a few months ago that we added layout tests and text tests, which are similar to what you find in WPT. Just load a page, wait for the load event, and then dump either the layout tree or the text content of the page. And we added them a couple of months ago, and we're up to like 200-something tests. So we're very, very, very small still in that department. And we don't yet run web platform tests. We have a runner under construction, actively under construction. Alex, who's also here, he has been working on getting the ref tests part of WPT up and running, and we are looking forward to getting more tests up and running. And then hopefully we can make a graph, and then, people will make the graph go up. Quick look at upcoming work. So performance is a big issue for us. We are very slow on almost everything because we are very unoptimized. So that's okay, because my job at Apple was to work on the WebKit and Safari performance. So I know what we need to do. I just need to do it again. But we've been kind of putting that aside and chasing correctness instead, and just chasing functionality and trying to get all the pieces into place. But I'm reasonably confident that we have a good enough architecture that we can put performance on top of that architecture without having to rejig everything. Memory safety is obviously an issue for anybody using C++. The approach that we are investigating right now is we are making a new language which transpiles to C++. And it's a new safe language, and it will allow us to incrementally transition to memory safety without having to deal with awkward boundaries between incompatible languages or very different languages. But yeah, I thought for a project that already makes its own operating system and its own web browser and its own everything, what's a language, right? Like, we can try that too. If it doesn't work out, it doesn't work out. But it seemed worth giving it a shot. So that's about a year old, but still not integrated in the browser engine. And then, of course, implementing specs, fixing bugs. That's our daily bread and butter. That's what I do almost every day these days, just fixing stuff. And we're going to have to keep doing that because although some pages look great, other pages do not. And that's what the work is about. Finally, I really want to just give credit to all of the people who have been working on Ladybird. This is far from everybody. These are just the people with 10 or more patches in the web or JS engines. There are hundreds of people who have contributed in one way or another, and it's been absolutely great to be able to bring so many people into browser hacking because it is something I love to do, probably something most of you love to do, and if we can get more people to do it, I think the future of browser hacking is looking good. So thank you to all of these people and more, and thank you for coming to my talk. And now you can ask me anything. Yeah, go ahead.
Yeah, so questions. Do we have questions?
Thank you for the talk. It was really interesting to hear that you are starting to consider putting in optimizations for performance. When can we expect a optimizing compiler in libjs?
Well, that's a good question. An optimizing compiler in libjs, it's something that I'm a little bit suspicious of. I know it's all the rage to optimize JavaScript, and people love writing, 10-tier JIT compilers and stuff. But I started using that lockdown mode in iOS when that came out, and they turn off the JIT, and the web is just fine. So I'm a little bit curious about how much can we really do without a JIT? Like, do we need a JIT? Do we need to make the security compromises, the complexity compromises that a JIT forces you to make? I don't know. So from my perspective, I think I'm most interested in exploring like how far can we push an architecture that doesn't make the sacrifices necessary for a JIT. That doesn't mean that we shouldn't optimize. We should probably optimize. We need to make a bytecode interpreter and make that really fast with all the techniques and stuff. But I'm curious about an alternate path, not necessarily what production engines do today.
Cool. We have one question here that someone has asked. What are the other language would you have chosen for Ladybird instead?
If I were building the project from scratch today, I would probably start by building a language. But if I had to pick one, maybe Swift. I am a big fan of Swift, but I stayed at Apple for long enough to become infected, so I have a little bit of Apple brain, and Swift just looks so good to me. I spent a bunch of time last year learning about Rust, and I think Rust does a lot of amazing things, a lot of cool tricks, and it's really good how Rust has embarrassed the language industry, hopefully embarrassed even C++ enough that they will take action and fix stuff. But that remains to be seen because the C++ does not move super fast, unlike code compiled in C++. So yeah, I think I would have used Swift, honestly.
Cool. I just have one follow-up. You mentioned the memory safety, and then that led to you working on something new. I don't know, did Rust cross your mind that time, maybe?
Yeah, absolutely, absolutely. It was one of the languages that I evaluated when we were looking for new languages to maybe switch to or adopt. I looked at basically all of the existing compiled safe languages today, spent a bunch of time learning Swift, a bunch of time learning Rust, and I know that this is not a popular opinion, but I like object-oriented programming. And I think on some level, we can all admit that whatever you think about object-oriented programming, the web is an object-oriented platform. It is designed around OO concepts, and that can be good, that can be bad, but we're stuck with it. And I think expressing the code that you want to express in a browser, it's really natural to use an OO-friendly language. And my feeling about Rust is that it's not OO-friendly, it's like OO hostile, I would even say. And that just feels like you have to contort yourself in ways that seem unnecessary. If you have the luxury of infinite patience and free time, and you're willing to build a new language for the heck of it, then why not try to build a perfect language for the domain? So that's kind of where I ended up. But the co-creator of the language that we're making is, by the way, a Rust core team member, or was until recently. So there's Rust DNA in the project as well.
Cool, thanks. I have lots of questions, but I think it's better if I ask some people here if they have questions.
Yeah, I have a question about the timeline slide.
Mm-hmm.
So, and lots of curiosity about it. So I mentioned that you basically grow in 3 years from a fun project to something which to me sounds massive, like the operating system plus a web browser, which is, it's not trivial, at least.
Sure.
And if I was doing this, I'm pretty sure that I would have to rewrite the whole thing at least a couple of times. So apparently you have lots of experience, kind of, which, and you're likely lucky, but still a question, did you make big mistakes on that way? Because to me it looks like you had to do lots of stuff, and it would be really like lucky not to do anything wrong in the process.
I've made a ton of mistakes. Oh, yeah, absolutely. The original implementation of layout was really, really bad because I essentially just implemented what I had seen WebKit do and how I thought that worked. Because I'd never worked on layout in WebKit. I just worked on other parts of WebKit, and I had seen patches to layout sometimes, and I thought I understood how it worked, and then that's how I built the first layout in our web engine. And it turned out to be really hard to extend and to improve anything in that way. And it also turns out I did not understand layout in WebKit. And I don't now either, but at least I spoke to the people working on layout in WebKit, and they told me, oh, well, you're building a new browser, here's what you should do. You shouldn't do what we did. We would never do that again. And they gave me some suggestions, and basically, which amounted to just read the spec and implement the spec. So that's kind of what we've been doing. It's really good advice, and it's really stupidly obvious, but it didn't occur to me at all at the time that we could do that. But yes, that was a big mistake. And really, anytime that there was a spec and we just decided to do something else because let's just do something easier, or something where we know how to do it instead of having to learn a new way of thinking about it from a spec, that was almost always a mistake because we've then had to go back and rewrite this thing to behave like the spec. A recent example of that is fetch. So now we implement the fetch primitive from the WhatWGG specs, and we're retargeting our web engine to use fetch for fetching images, fetching style sheets, scripts, and that is fixing a lot of bugs that we didn't even know we had. And it's just been really great. We should have done that earlier. And if I think longer, I can think of more mistakes. Those are just some obvious ones.
Okay. If I said I wanted to embed libjs for scripting in my application, what would you tell me? What would I have to do in order to do that?
Well, I know that there's somebody who already did that. I forget what it was. It was some Minecraft thing or something. There's somebody who already put it into a game thing. And what you have to do, I guess, is just figure out what is the smallest set of dependencies that you would have to bring from us, because we are a fairly tightly integrated kit. We don't use like the C++ standard library. We have our own standard library. We have everything of our own. So if you just find like the smallest bounding rect of libraries from us that you need, and then you can lift those over, and then you can look at one of our little sample programs that talk to the JS API and have something up and running pretty quickly. As long as you can compile it, it'll work.
Okay.
Hey, thanks. Like, first of all, like that's pretty impressive work. Like, and I found your YouTube channel like a long time ago, and you're doing great. But
thank you.
I was wondering about how deep the Ladybird platform integration is, right? So like, presumably LeafJFX does mostly software rendering, and like, you draw like your own like scroll bars and widgets and all that kind of stuff. Is that right, or do you do anything more like complicated for like?
It is. You're basically right. It's a software rasterizer, pretty naive 2D graphics library. We only just recently got nice-looking anti-aliased path filling. We had really ugly path fills for a long time, and we just put up with it. But yeah, we have a graphics library that just contains everything needed for rendering Serenity OS, and then we just took that, brought it with us to Linux, to Mac OS, and compile that there, and we use that. So it doesn't use any kind of GPU stuff. It doesn't call out to platform APIs. The only exception is that we use Qt, but the only thing we do with Qt is we take the finished bitmap of the web page that we rendered with our own stuff, and we put that into a Q image and then put that on the screen. So it's extremely thin. And this is definitely an area that we have to do something about, speaking of performance earlier, because we do see in profiles just a lot of time disappearing into stuff like painting shadows or anti-aliasing, stuff that you take for granted if you use a mature library that this would be fast, but if you use something that we just put together quickly and didn't even know how to do, we do have those kind of performance problems. But they improve over time. People are actively picking up random parts and improving them. And I think if we can do something that uses the GPU eventually, that would be huge. There's a little bit of an issue there in that we don't have GPU support on Serenity OS, not very good one anyway. So we've kind of been held back by that in a sense, because we don't have abstractions on top of a GPU that you might otherwise have. We have all kinds of abstractions, but nothing good for accelerated rendering. But somewhat recently, people have been implementing, what's it called, VirGL, which is like virtual GPU support. VirtGPU, maybe it's called. So you can have like hardware acceleration in QEMU or VMware environments, and if we have that, we can build an abstraction, and then we can use that abstraction to put in our browser and one day have really fast GPU stuff. I don't know. We'll get there. There's a million cool, awesome things like that that we want to do, that we should do, and we will do eventually. It's just, which thing do you do first? That's really the big problem. And of course, I never mentioned, but like, this is an open source project. Obviously, everybody's welcome to work on it. If anybody finds any of this interesting or just fun to tinker with, There's always room for more hackers and tinkerers. Yeah.
I think I saw someone, yeah.
Hi, Andreas. So,
hi, Nico.
Obviously, impressive work. So I was wondering, do you have any time left for Serenity OS now that you have started an endless fun project?
Time left for Serenity OS?
Now that you have Ladybird?
Yes, I have infinite time for everything.
That's very good. So
the only problem is I'll die, but I'll deal with that then.
That brings me to my real question. You said in the beginning, so real web pages is a focus. So how about media playback?
Media playback?
Yeah. Do you have support for media playback?
Right. So we got pretty recently, Tim, our friend of the project, Tim, added media element, video element, and hooked that up so that we can use those. Of course, those are no fun if you don't have codecs. And Gregory, who also works on Firefox every now and then, wrote a VP9 decoder for us. And now we hooked all those things up so we can play VP9 videos in the browser. And he had a cool demo where he downloaded a YouTube video and played the video. So that worked in the browser, but we don't have the media source extensions or whatever it's called yet, so we can't actually like play it live on YouTube. But the machinery for playing the video, once we know how to fetch it, that is there. So that's something we're obviously looking forward to, the first YouTube playback. I just realized I should have made a slide about this because I had a cool first on the way here. When I was at the airport, I logged into this free Wi-Fi hotspot using Ladybird. That was pretty sweet. Sure.
Hi.
Hello.
You mentioned wanting to contribute to specs and fix bugs there and stuff, and you also mentioned heat testing. There isn't currently a spec with heat testing, and if you don't know too much, you might think this is not such a big deal, but like there's a lot of complications. Some of the stuff that I had to do a bit related to that in Chromium was what do you do with bid if you click on text and there's maybe a bit boundary or something and at the end of the line and stuff, and that is not easy exactly. So have you considered working on a hit testing spec?
I can't say that I have, but I've seen the emails where people talk about, hey, why isn't there a hit testing spec? Coming soon. No, it's I sympathize with anybody who complains about this because, of course, we had to implement hit testing from scratch with no spec, and I don't think we've figured it out just yet how it should work because it's definitely not correct all the time. It is very hard to hit test web pages, especially when with stuff like bidirectional text. Of course, we have a great solution for that, which is to just run away. But one day we're going to have to handle bidirectional text better. But we also have to write, like, as you saw, we have the libgraphics stuff, which does text layout, text rasterization. So we have to like implement all of that stuff as well in our OpenType parser and implement shaping and glyph positioning and yada, 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 before we'll even get to worrying about clicking in the right place. But to your question, I don't think I would work on any spec anytime soon because I'm busy trying to implement the specs that exist. However, I will gladly contribute to existing specs and fixing or trying to fix anything I come across that like, oh, this is missing or this is wrong or whatever. We're trying to be good citizens about that. We can definitely be better. And it's only recently, really, that it's gotten to the point where it feels like maybe the spec is wrong, rather than obviously we're wrong. So we don't have a lot of experience feeling like maybe we're doing it right just yet. This is new to us. Yeah, I hope that made sense.
Do we have?
Hello.
So, actually, I have a couple of comments and a couple of questions, but I don't know how much time we still have. But first of all, it's, as everyone has already mentioned, it is extremely pleasant to watch, such a community forge growing up from the start. I think I remember the car talks that you used to have. How do you used to call those? The community talks that you drive in the car and talking about things, not necessarily having a draft schedule of topics to talk about. But what we see about Serenity OS and about the browser now, the Ladybird browser, is that you are able to engage lots of folks to join and to contribute to the project. And there is a couple of things that I think help with that. One of the things is that quality is there. So people want to contribute to something that they find, there's quality here, and I'm going to add a little bit here. There is your usage of the YouTube videos that you produce. There is Twitter. But do you think there is anything extra other than that to help with engaging all those folks? And that's question number one. And why I mentioned that, we, just before your talk, were watching Dylan's talk about Servo, which is another piece of software, another web engine that's out there. It has its own state of completeness. But we're still, growing up in terms of engaging folks and getting random folks to, okay, there is also Servo to contribute to, and there is Rust as a language to learn and all this stuff. And you've managed that with Serenity OS and with Ladybug. What do you think is kind of secret key about all that stuff? What, other than, as I said, quality and your usage of internet, to help other communities to also grow? Maybe you've thought of that already, but I just wanted to hear your thoughts about this.
Well, I think you kind of answered the question for the most part. Like the usage of the internet, as you call it, I think that helps a ton. So many people have started hacking on Serenity OS or on Ladybird because they just saw my YouTube videos where I'm working on something and they thought, hey, he screwed up here. I can fix that. And sometimes, like, there would be these people who would comment on my videos, like 5 videos in a row, like, here's a mistake you made. You made a mistake there. And I would tell them every time, like, can you just make a PR? And eventually, they would bend and make a PR. And we converted one person. And I've put out, like, over 1,000 videos on YouTube. So I've been doing this for a while. It's really consistent. And that has been, I think, like the biggest source of new contributors just coming in that way. And I know that it's not something that's easy to replicate, and I don't even know if it would work. But I think if you distill it down, what I was really doing was just making a lot of content and like regular content about the projects I'm working on. So I think you could probably do the same if you write a lot about it, if you write in an engaging way, or if you stream, or if you make videos, or make something else, just something where people can follow along until they develop enough curiosity to try to do something themselves. I don't know, video was just a format that I happened to try for that. I think you could do it with many other formats. And probably other people could answer this better than I can, but I really think that is sort of the secret sauce, because at least that's where I see most people attaching from. And then, of course, you can only do so much to like bring people to you. Then you have to keep them, and for that, that's a whole other thing. You got to have something fun. If you make something boring and then you make cool videos about it, people are probably not going to stay very long anyway. So it has to be cool to work on. We try to keep it cool. I hope it is.
Yes. Yeah, that answers. One more question. Have you ever done any mapping of who are those folks contributing? Are they like just grad folks, or are they, as you said, one of the browser core contributors that, okay, let me help out with these folks there? Have you ever kind of mapped who are those folks contributing, where they're coming from? Are they from different communities at this point, or they started with Serenity, so they start clean and I can, grow with them on the project?
I can't say that I've been tracking people too much. I think for anybody in the browser business, we should be careful about tracking. But we do have like a volunteer user map where people can put a little pin for themselves so we can see sort of how the community is spread across the world. And we did find that there are a lot of Germans. For whatever reason, Germans are super into open source, I think. Always have been. When I was working on KDE back in the mid-2000s, there were so many Germans, and Germans are great. They just love open source. And we have a lot of Germans in our open source project too. And it's a fairly European project, I guess I would say. It's like, if you look at the map, you see a lot of Europeans and a lot of like West Coast Americans, and then dots here and there, but concentrated in the European area. And I think it's a lot of young people, probably to do with me using YouTube as the bait to get people in. You don't get that many older adults watching YouTube, or maybe you do. I don't know. I don't. I look at my audience demographics sometimes, and it says like male 19 to 34 is 99.9% of my audience. So make of that what you will. It's the best I can do with the data I have.
I'm tempted to ask how you keep it fun, because you didn't elaborate, but I'm not going to. I'm going to ask a different question, which is just, how has decision-making evolved as you've gotten more active contributions and contributors?
So decision-making we haven't had that many decisions to make, because it's fairly clear what we're building. Like, we're just building a browser, and the browser needs all of this functionality, and for the most part, it's kind of obvious what work needs to be done. But there was when the project first started, it was like a repo in my GitHub account. And eventually I moved it to an organization, and eventually I changed the license of the projects to say copyright me to copyright the project, or something like that. And eventually I could no longer deal with the pull request queue, so I had to start inviting people to co-maintain the project. And eventually it was too much for 2 people, and eventually it was too much for 3 people, and so on. And nowadays I think there's 10 of us or something like that maintain the project. But for the most part, I would say it's just obvious what needs to be done. So people just work on their things that they are interested in, and somehow it just becomes a browser, and it becomes an operating system. And there have been very, very few cases where I go in and I say like, oh, wait a minute, I final veto this random thing because I think this is going in the wrong direction. If I look at my own number of rejected pull requests out of thousands, I think I've rejected less than 15 ever. So we're very accepting of all kinds of ideas that people have. And I've talked about it many times as kind of like a hacker's playground, because we don't have releases, we don't have a schedule, we don't have a plan. People are welcome to come and just enjoy themselves by working on a serious project, but a fun project. So it's a little bit unusual.
We have one question from Brian. What does your UA string claim to be?
My UA string? We are honest with our UA string, which bites us in the butt every now and then. So we say that we are Ladybird, LibWeb, and LibJS, and We do have the mandatory like Mozilla /5.0 or whatever, because the spec says you have to. But outside of that, we just say who we really are. And there are many websites, even big companies who should know better, like Google, where they just look at your UA string and they just tell you to disappear. I think Google sign-on, for example, it's something that just doesn't work unless we lie about our UA. And I think for the longest time we thought that we can tell the truth and the internet will get better, but the internet doesn't get better. Yeah, I mean, we're gonna try, but we can only do so much with our 5 active users or whatever. But I think realistically, we're gonna have to do something where we have a list of bad servers and what lie to tell them, because otherwise we can't render certain websites. And we I mean, on the web, there's spec correct and there's pragmatic correct. And we're going to have to choose the pragmatic option and lie a little bit. Otherwise, we won't have a browser that's usable. But we're going to tell the truth as much as possible. Also, if anyone knows where to complain to Google about this type of stuff.
They will not accept the complaint.
Oh, I'm sure they won't, yeah. But at least I would feel good if I complain.
Okay, one more question from Matrix. What can you recommend to get up on speed with Ladybird and its code?
Ooh, that's a good question. I guess I would recommend getting the code and building it, and then loading up your favorite website and seeing what happens. And if it doesn't work, which it probably won't, then see if you can figure out why it doesn't work, or at least isolate something that you can tell, like, oh, this thing doesn't work. And once people get into doing that, usually one thing leads to another, and before they know it, they are fixing it. So that's what I would suggest. Just try it out. See what happens.
Thank you. Do we have more questions here? Cool. All right. Thank you, Andreas, and thank you, everyone who asked questions.
Yeah, thank you.